So this is our good friend, the periodic table. We need to have a little bit of a guided tour around it. We'll probably do this a couple of times. But you need to know that going down the periodic table, you've got groups. So those are the groups. Going across the periodic table, we have got periods. I'm just going to make this a tiny bit smaller. There we go. So across like that are going to be the periods. So this is period number 1, period 2, period 3, period 4, period 5, period 6, etc. Going down, we've got group 1, group 2. Things get a little bit hairy over here. Group 3, your periodic table might say group 13. Ignore that, just call it 3, 4, 5, not 15, 6, not 16, 7, not 17, and 8, not 18. Okay, for your purposes, that will work just fine. This little bit of the periodic table over here is called the transition elements or the transition metals. And these are known as the inner transitions or inner transition metals. Sometimes called the lanthanides and actinides as well, but we do nothing with them at all. And then finally you need to know just a couple of little names, and that is that group 1 are called the alkali metals. I recommend that you're decorating a periodic table of your own at this point. The group 2 are called the alkaline earth metals. Group 7 are called the halogens. NS, sorry, squashed a bit there. And group 8 are called the noble gases. I think it's EL actually. Can't spell. Alright, moving on. So here's a little guided tour. It tells you what's going on. That's what we've just discussed right now. These are some of the names that we've just discussed. The chalcogens, it's there and thereabouts, but it doesn't get used nearly as often as the other 4 over here. These are the elements that you are going to need to learn off by heart this year. I've got them very clearly laid out in the list. So we start off with the first 20 elements, okay, so up to calcium. That shouldn't be very difficult, you're all the way up to there. And then there are selected transition elements and elements further down the periodic table that you need to know. Manganese looks a hell of a lot like magnesium. You need to be careful of that. Potassium is not the same as phosphorus. You need to be careful of that. Sodium is Na, which is just weird. It's got to do with the fact that in Germanic languages it's natrium. The same with potassium, by the way. Potassium in Germanic languages is gallium. So that kind of works like that. Ag is silver, from the French argent, silver pieces. And aurium is, or aura is gold. Now if you look at the old pictures where they used to put like a halo around biblical figures' heads, that is their aura, and it was always golden, so that's Au. Lead comes from plumbium, which is like plumbers. They used to make all the piping out of lead. So you know that a plumber is a person who works with piping, and PB comes from that. So those are some of the derivatives of different. Iron comes from the Latin ferrous, and if you think about something like a Ferris wheel, it was made all out of iron, the big circular wheels. So those are some ways of remembering all of these, but you do need to commission those to memory. You don't have to commission these to memory. These do not need to be learned this year. They'll have to be learned by grade 11. I will always give these to you in a test or an exam. They are known as the polyatomic ions. And polyatomic ions do not need to be learned. There's the ammonium, which is different from ammonia. Silver, zinc, permanganate, nitrate, nitrite, nitride, hydroxide, chloride, bicarbonate, sulfide, sulfate, sulfide, carbonate, chromate, dichromate, and phosphate. So they're all given over there, and you will only have to learn how to use them. And I will explain how to use them at some later stage. They all have something called a valency. We'll discuss that a bit later. These are some other useful formulae. Good news about them. You don't have to learn them either. You'll become familiar with some of them, I hope. I hope you know what water is already. But you don't have to learn these off by heart either. I will give them to you this year. These are things called diatomic gases: hydrogen, oxygen, nitrogen, bromine, iodine, fluorine, chlorine. The acids are all here: water and ammonia, NH3, which is different from ammonium, which is NH4+. And then you've got your carbon dioxide, your sulfur dioxide, and your nitrogen dioxide. Again, don't learn. It will be given to you. When you name ions, metals always keep their name straight from the periodic table. So let's take something simple like sodium chloride. Sodium is a metal, and chloride used to be chlorine, but when she gets married, she changes her surname to chloride. So the negative ions, or the non-metals, will change their name to have an "ide" suffix. So you'll get chloride and sulfide and oxide and bromide. The only exception to the "ide" thing is hydroxide, which is a polyatomic ion called OH-. I'm introducing you to a whole lot of vocabulary now. Don't panic about it. We'll learn how to use it a little bit more, but I need to introduce you to it to get started. Right, let's discuss atoms and molecules quickly. You've done this already, but we'll go over it. The atom is the smallest particle of an element that has all the properties of that element. An element can be found on the periodic table. Elements make up all matter and are made up of atoms. Atoms make up elements. All atoms of the same element are the same, so sodium is just sodium atoms. Helium is made up of only helium atoms. Molecules are the smallest particles of compounds, and they have all the properties of that compound. A compound is made up of atoms combined together specifically. This year we're going to focus a bit more on this specific ratio business. So if I take a look at something like 5H2O, we'll discuss that in a second. Sorry, what is the difference between O2 and 2O? O2 would be 2 oxygen atoms joined together. 2O would be 2 oxygen atoms far apart. This subscript O, at least the subscript 2, tells me that they are joined together in a molecule. And if I look at the this number in front, tells me that I've got separate particles. So, what does this formula tells me? That tells me I've got 5 separate particles of H2O. 5 separate H2Os. Okay, which means all together I have got 10 hydrogens and I have got 5 oxygens. H2O is water, combined hydrogen and oxygen in a specific ratio. So, take a look at this, press pause and try and work through this table on a piece of paper, and only once you have completed it, take a look onwards. Alright, let's just look at that. We've got capital letters symbolize elements. So there's hydrogen here, only 1 hydrogen and chlorine 2, carbon and oxygen 2, hydrogen and oxygen 2 elements, nitrogen and hydrogen 2 elements, nitrogen, hydrogen, oxygen, hydrogen's the same, so 3 elements, nitrogen, hydrogen, carbon and oxygen 4 elements. Looking at the number of atoms, there are 2 here. There's 2 times 7, 14. 1, 2, 3 times 2, 6. 1, 2, 3, 3, 4. 4, 5, 6, 7. Multiplied by the big 3 in front, 21. This one's a little bit more tricky. This 2 on the outside belongs to both the nitrogen and the hydrogen. So it's 2 times 4, 8. 2 times 1, 2, 10. Plus 1, plus 3. So that's 14 altogether. Multiplied by 6 gives me 84. One molecule of a compound, press pause, do this, and then we'll go through it together. So, if we're going to have 1 atom of copper, 1 of sulfur, and 4 of oxygen in one molecule, it's Cu, SO, and subscript 4. How many oxygen atoms are there in 3 KClO3s? I put a big fat 3 in front. 3 times 3 equals 9. 3 times 3. What can you get from this formula? How many elements are there? Hydrogen, sulfur, oxygen, 3 elements. How many atoms? 2 plus 4 plus 1 is 7. How many sulfur atoms are there in 3? So if I were to put a 3 in front of H2SO4, I would simply say 3 times 1 is 3. But on the other hand, if I were to say 4 H2SO4, how many oxygens are there? I would say 4 times 4, 16. What is the meaning of this number 3 in the front over here? It means that there are 3 molecules of ammonium sulfate. 3 molecules is enough for you at this point.